to see, we are talking, and in this video we are going to see about. Hi guys, today in this video we are going to talk about graphene. So it is an interesting element. It has future dependent. The future is dependent on this, and it has vast applications which we will be discussing later in this video. So coming to graphene, how it's made actually. So simply we can discuss the preparation of graphene in some like this. So as the lead of the pencil tip contains graphite, by removing layer by layer, the final layer we will be getting the graphene from tape. It will be 2D structure with negligible thickness, atom thickness, and weight will be like 0.78 grams, and again the strongest material, strongest structure possible. Actually, it's a single layer after removing so many layers of graphite. So the single layer has been like made in this benzene ring shape actually. So this has been placed like this. The structure is like this. Now coming to the properties. So it will be very rigid actually, because the voids will be less, so the strength will be more. So it's like strongest element than diamond actually. And again, it has thermal conductivity and electric conductivity at peaks. So it is the highest thermal conductive material and electric conductive material. And so research has been going from 19th century onwards, and again in 2004 the application or the product has been shown, and in 2010 they got the Nobel Prize also for this. And now it has applications in medical and engineering fields everywhere. Actually, the future will be this material. It can be used in TVs, displays, everywhere actually, in cameras, shutters, like camera lenses, and in your like shirts, everywhere, in clothes. It's like it will be very miniature thing, but has vast applications which we will be seeing in the later part of this video. The applications of it, everything. So coming to the applications of graphene, we have so many applications like energy storage, ultrafiltration, optical electronics, composite materials, photovoltaic cells. And in this we have so many sub applications, so we'll be going through everything. So for energy storage, we have supercapacitor as its sub application. So coming like now, energy storage has been a biggest problem. Like we are not able to store the energy, we are consuming energy very rapidly, that we are not dealing with saving it. So we are coming up with new innovations using the graphene supercapacitor application. Like nowadays batteries used to store a lot of capacity of energy actually, but capacitor, indeed, it can't store the lot of capacity, but it can give you faster rates of recharging. But the battery is not the case actually in that sense. So taking all the pros from the both applications, we are going to deal with new application known as supercapacitor. So in this, what we are going to take is like we can store huge capacity, at the same time we can recharge rapidly. For that, at first research being conducted, in which like lithium ion batteries which we are using. So we are using graphene material in anode part of that battery, so that it can store a huge amount of capacity with faster rate of recharging time. And again, for mobiles and like mobility devices, mobile devices, we are using like micro supercapacitors, like small in size, so that it will be capable to fit in it and give you sweet results. And again, we can incorporate or enhance the lithium ion battery with supercapacitors or graphene material to be able to use in like bigger vehicles, battery vehicles, etc. everything. And again, lithium can be used with this supercapacitor or graphene material for smaller size materials like phones, mobiles, etc. Now moving to ultrafiltration. Now for ultrafiltration we have sub applications like water filtration, radioactive disposal, speakers, diaphragm. So coming to radioactive disposal, here what happens means, like if an atom bomb or something, radioactive material has been fissioned or fusioned, anything, so that waste should be disposed. So graphene acts as nice absorbent where we can use this as a disposal package or anything, so we can keep all the waste in it so it can absorb. So it acts like a radioactive disposal. And again, water filtration, the small pores, as graphite is a 2D structure, it doesn't have any thickness. The voids between it are so small such that the water can pass through it and the waste will be deposited back only from where it started to be filtered. Like in this pictorial representation, if we consider this to be salt water, the black portion, so we are placing graphene material, anything, the dotted one, so that dotted portion indicates the voids so that the water can pass in and the waste will be deposited in the salt water side only. So in this side, the other side will get in the pure water. And this graphene acts like a speakers, they act like diaphragm, so they can be placed in our earbuds, everywhere. Actually what happens now, electric signals or any signal, when it passes through, they get excited and it produces nice bass and audio effects. Now coming to optical electronics, we have sub applications as night vision cameras. Yeah, this can be used in night vision cameras so that the objects can be very picture clear, ultra clear. This can be used in displays. Actually nowadays we are using indium tin oxide displays. It can replace it, giving a better quality because of its optical transparency. And this can also be used in flexible electronics, making it flexible and can be made portable because of its tensile strength and strong bonding and a strong bond between the atoms. And actually, like, it can replace OLED displays, LCD displays. The kind of material the optoelectronic device uses, actually they are somewhat light resistant, like they will not transmit total light, so 90% they will transmit. So but here using this material we can increase that efficiency to about 97%, so it enhances its efficiency. Now these can also be used as composite materials. So the sub applications for composite materials include artificial muscles, rust proofing. So coming to rust proofing, like we get rust because of using some materials, so using graphene we can avoid that rust, so it acts as rust proofing. And now coming to artificial muscles, so these materials are strongly bonded, so whenever we stretch it, it regains its original shape. So we can use this in any polymer or synthetic rubber, stretching it and pasting or adding it on the top of it, so that whenever we stretch again, so whenever an action is made using that total equipment, it will be staying in the state, and once the action has been done, it comes to its original shape. So again it helps in artificial muscle making, etc. And now coming to photovoltaic cell application. So due to its low absorption, like it will transmit everything of white light, or like minimal, and electron mobility is high, so it can replace silicon, so it can be used everywhere where silicon is being used. So we can say like quantum computers as an example. In that transistor, as you can see, the two points are there, the connection between the 2 points is known as channels. So we can replace those channels using this graphene material, getting low heat loss and ultimate speeds. These are very few examples of application, but these are major applications of graphene material. It has lot of advantage because of its strength and its properties. That's a wholesome video. It sums up, wraps up everything. So let's hope to see you in the next video. Until then, signing off. See you.